Okay, now we are going for the fifth IPSEC session. We are going to talk about IQ version 1 configurations. We are going to include in this session IQ version 1 phase 1 config, phase 2 config, policy-based versus route-based VPNs, cryptomap VPNs, IPSEC profile using GRE VPNs, and IPSEC profiles using BTI VPNs. In order to show how to configure these, I have set up these routers. They have the same topology, they have the same IP addressing, they already have tunnels configured with the same IP addresses. We are going to configure several types of VPNs using IQ version 1 configs. So in order to configure a VPN, you have to go first through configuring IPSEC phase 1, and then you will have to configure IPSEC phase 2 to finally perform the actual VPN configuration settings. Remember that we are going to show how to do these using IQ version 1 commands. So let's go for phase 1 first. Remember that we're talking about IQ version 1. You can set up several policies. You need to configure at least one policy, but you can configure as many policies as you want. Each policy is actually a combination of settings. So we are going to combine a specific authentication method with a specific encryption algorithm, with a specific hashing algorithm, with a specific Diffie-Hellman group, with a specific lifetime for this policy. You might wonder, why do you need more than one policy? You might need more than one policy if you have several type of remote peers that you want to establish IPSEC conversations with, and these remote peers happens to support different combinations of settings. So in those cases, you might need to have more than one policy. But if all your remote peers are of the same kind and they are configured the same with the same combination of settings, you might need only one policy. Then optionally, you can set up other IPSEC phase 1 settings. This is not mandatory, but what is mandatory is to configure authentication. So these are the commands for phase 1. For instance, crypto ISACAM policy and the number of the policy for creating policies. These are the commands for some optional settings. And in order to create authentication or configure authentication, in this case, we're going to go for pre-share key. We're going to use these commands. So let's go and configure that in the actual routers. So we're going to try to use the same configuration for all the routers. And we're going to go first for the policy. So remember that we're configuring phase 1. So we're going to configure one policy where we are going to set up the authentication method. In this case will be pre-share. The encryption algorithm, we're going to use this. And the hashing algorithm, in this case we're going to use MD5. The Diffie-Hellman group, we're going to select number 1. And the lifetime, we are going to leave this as is. And by default, it is 1 day for IQ version 1 phase 1. And the other mandatory configuration that we need is the key. In this case, we're going to use crypto ISACAM key. The key is actually my key. You should use key that is not guessable. This is just for to show an example. And then the remote IP addresses that will support this key. In this case, by issuing 0.0.0.0, we are enabling all remote peers to be able to authenticate with this key. Now, we can issue show crypto ISACAM policy in order to see our policy. Now we are going to replicate this configuration. So all the phase 1 configuration will be the same for all our routers. So policy and pre-share key. Just remember that we are using encryption algorithms, hashing algorithms and Diffie-Hellman groups that you should not use in production environments. I'm just using these ones because they do not stress the CPU. And this will be my phase 1 configuration for IPSEC. So let's go for phase 2. For phase 2, we are going to configure that what we are going to call transform sets. We can have one transform set, two transform sets, or as many transform sets as you want. The command to create this transform set is crypto IPSEC transform set. You might need to have several transform sets if you have different types of remote peers that support different combinations for settings for phase 2. But if you have the same type of remote peers that support the same set of settings or the same combination of settings, you might only need one transform set. But that depends on your network. So the transform set, with the transform set, we can select the protocol. For instance, with this example, we are selecting the AH protocol. In this example, we are selecting the ESP protocol. And in this example, we are selecting the combination of authentication, header plus ESP protocols. We are also selecting the algorithms, the hashing algorithms, and the encryption algorithms. Now the commands for phase 2 is always the same: crypto IPSEC transform set, the name of the transform set, and then the options, where in the options we are selecting the protocol and the algorithm. So let's do that in our devices. We are going to create only one transform set because all our devices are going to use practically the same settings. So crypto IPSEC transform set, we're going to call this T1, and we are going to select the more friendly IPSEC protocol, which is AH, that does not support encryption, only hashing. So we are going to select AH because we want to capture some traffic later on and be able to see how IPSEC is actually encapsulating the contents of the protected traffic. And then after doing this, we are going to have to select in what mode we want these protocols to operate with. We can use transport mode or tunnel mode. By default, tunnel mode is in use. We are going to leave this as is. We want tunnel mode to work, and that will be all for phase 2. Let's replicate this in all our routers. So we are going to use only one transform. So let's go now for the VPNs. This is an important topic: policy-based VPNs and route-based VPNs. As time went by, we have evolved the way that we create VPNs. Originally, we had policy-based VPNs. These really don't get along with routing protocols because policy-based VPNs don't really establish IPsec conversations that are attached to different interfaces. So routing protocols usually like to run over specific interfaces. However, policy-based VPNs do not provide the specific interfaces protected by IPsec. So that is one of the characteristics of policy-based VPNs. We have, for instance, crypto maps that are an example of policy-based VPNs. They are attached to wide area network interfaces where some traffic is encrypted and some other traffic is not encrypted. So it is actually quite hard to troubleshoot policy-based VPNs because you don't have a specific interfaces to work with. Now, compare that with route-based VPNs that get along pretty much with routing protocols, because with route-based VPNs, we are going to attach IPsec to specific interfaces. More specifically, we are going to use tunnels. So we are going to have tunnels protected by IPsec, and then we can attach these tunnel interfaces to specific routing protocols. We have, for instance, IPsec profiles as examples of Cisco route-based VPNs. So let's go and configure these VPNs. Remember that regardless of the VPNs that you are choosing, the phase 1 and phase 2 configuration remains the same. So let's go for CryptoMap. CryptoMap is an example of a policy-based VPN. We are going to have to create first an access control list that defines something that we call interesting traffic. So given this VPN is attached to a wide area network interface, some of the traffic that is going to travel to the wide area network interface is going to be encrypted and protected by IPsec, and some other traffic will not be encrypted. So in order to define what is the traffic that is going to be encrypted, we are going to need this ACL that defines this, that we are going to call this interesting traffic. The first time this interesting traffic travels through the wide area network interface, it is going to trigger IPsec. Before that, IPsec remains dormant and it is not doing anything. But once interesting traffic travels through this interface, it is IPsec is going to wake up and start negotiating settings with a remote peer. And then further traffic that is interesting traffic is going to be encrypted. Now that we set up this ACL, we are going to use it when configuring the actual CryptoMap. We are going to also select a transform set within the CryptoMap, and we are going to have to establish what is the peer IP address. That is usually the wide area network interface of our remote peers most of the time. And then we can apply this CryptoMap to a wide area network interface. So in summary, we are going to create an access list to define interesting traffic, which is the traffic that is going to trigger IPsec and is the traffic that is going to be protected by IPsec. We are going to use this access list when defining my CryptoMap. And the CryptoMaps are defined by the random number and random name. We can define this name as we want. We have sequence number. Each sequence number may have different access control lists, different transform set, and different peer IP address. And once we have created the CryptoMap, we are going to attach that to a wide area network interface. So let's create a CryptoMap VPN with our devices. It is actually pretty easy. We first want to create our access list. In this case, we are going to detect all GRE traffic. And we can, for instance, detect all the IP addressing that belongs to the tunnels. In this case, 192, 168, whatever, 192, 168, whatever. This will be our interesting traffic. Now let's create the CryptoMap. CryptoMap, my map, sequence 1. The type of CryptoMap is IPsec ISACamp. We are going to match the access list that we just created. We are going to select a transform set, and we are going to set the peer IP address, which is the remote IP address. And then we are going to attach this route map to a wide area network interface. We can issue show CryptoMap to see that it is created. Sequence 1 has this peer IP address. Sequence 1 has this interesting traffic that is going to trigger IPsec. It uses this transform set and it is attached to this interface. Let's do that here. we are going to create the access list first that is going to define my interesting traffic that is going to trigger IPSEC, and it is going to be protected by IPSEC. So it will be GRE traffic and probably any traffic that happens to have the IP addressing that we are going to use for these tunnels. So 192, 168, whatever will be my interesting traffic besides GRE traffic. Now let's create the crypto map. My map sequence 1 of type IPSEC ISACAMP. Let's match the access list that we just created. We are going to use this transform set configured for phase 2, and then we are going to set the peer as the remote peer address. And then we are going to assign this crypto map to the wide area network interface. Show crypto map. So let's, for instance, capture that traffic and let's ping these devices to each other. So for instance, if I ping the other device, this is not interesting traffic because this traffic does not match this access list. So this traffic travels as is. It is not protected by IPsec. But what happens if I ping another IP address? Let's check first that IPsec is actually dormant. IPsec has not kicked in yet. There is no security association at all. Now let's see what happens if I ping the tunnel on the other side. It is going to take a little bit of time here in order to set up IPsec. So IPsec wakes up because now we are sending interesting traffic through the wide area network interface. Now a security association is built for phase 1 and for phase 2. Remember that we have an inbound security association and an outbound security association for phase 2. And the capture will tell us that we are now negotiating IPsec. IPsec wait up and it negotiated traffic with 10.12.10.1, and then all the traffic that is actually interesting traffic is protected by IPsec. So in this case, we have the ping that is encapsulated by GRE that is protected by IPsec. So notice that we have 3 IP headers: the original IP headers that corresponds to the ping, then the IP header that GRE adds, and then the IP header that IPsec is adding. We can see all of this because we are not performing encryption thanks to our choosing of this IPsec protocol, which is an authentication header. So that is how crypto maps work. Now let's go and see another option for VPNs, which is IPsec profile. With IPsec profiles, we have what we call route-based VPNs. These types of VPNs are more friendly with routing protocols because the IPsec profile is attached to a particular tunnel interface. So first we're going to create the IPsec profile, and then we are going to attach it to a tunnel interface, and that is all we need to create a VPN connection. So let's do that. Let's do that between router 3 and router 4. We already have phase 1 and phase 2 configuration in place. All we need to do is creating the crypto map, crypto IPsec, the IPsec profile, I'm sorry. So let's do crypto IPsec profile, my profile, and let's select a transform set, which will be T1 that we just created previously. And then we are going to go into the tunnel, and when issuing tunnel protection, IPsec profile, my profile, that will be it. That is all I need to do. Let's go for router 4 and do the same. Crypto IPsec profile, my profile, we are going to choose a transform set. Then we are going to go to the tunnel and using the command tunnel protection IPsec profile, my profile, we are going to protect it, and that's it. Let's capture traffic here. And then also notice that IPsec is already running. So for instance, if I issue show crypto ISECAM SA, I can see that we have security association for phase 1 and phase 2. So if we ping them, we will see that between router 3 and 4, we have IPsec protecting this traffic. So remember that we have one IP header for the original traffic, one IP header for GRE, and one IP header for IPsec. So if we issue, for instance, show interface tunnel, this tunnel is using GRE. It is protected by IPsec, but it is using GRE. And we can see that in the capture. So we have a GRE header and new IP header created by GRE because GRE is encapsulating this ping, but IPsec is encapsulating GRE. Now let's go for the third option that we have out there, which is IPsec profile with VTIs. Now the configuration is pretty similar to what we just saw. We are going to create an IPsec profile. We are going to attach this IPsec profile to a tunnel interface, and then we are going to change the transport. We are going to get rid of GRE with this option. We are going to be able to create pure IPsec transport in tunnel mode in order to move packets. So we are going to configure the IPsec profile. Then we are going to protect the tunnel interface with this IPsec profile, and then we are going to change the mode of the tunnel in such a way that we are going to get rid of GRE. So this will be a pure IPsec transport. So let's configure that. Let's go to these two devices. In this case, we are using iOS XE. We are not using traditional iOS. So let's configure this profile with VTI. So crypto IPsec profile, my profile, we are going to use this transform set. Then we are going to go to the tunnel and we are going to use tunnel protection IPsec profile, my profile, and then we are going to change the tunnel mode. Tunnel mode will be IPsec IPv4. So we are going to use native IPsec transport rather than using GRE. We are going to do the same here. So it's going to be crypto IPsec profile, my profile. We are going to use this transform set that comes from phase 2. Then we are going to go to tunnel mode, and we are going to issue tunnel protection IPsec profile, my profile, and then we are going to change the mode of the tunnel mode IPsec IPv4. So we are going to get rid of GRE. So if we issue show interface tunnel, we can see now that the transport is IPsec. The protocol is IPsec, and this tunnel is protected by IPsec. If we compare that with the other VPN, the protocol is GRE, protected by IPsec. Compare that with protocol IPsec, protected by IPsec. Now let's see what happens if we ping the other side. So let's see the capture for this ping, and let's compare that with the previous capture. So notice that in this case, we only have the original ICMP packet with its IP header, with its original IP header encapsulated by IPSEC. So there's only one encapsulation going on here. Compare that with the previous ways to create VPNs with GRE, where we have two encapsulations: original IP header, first GRE encapsulation, and second IPSEC encapsulation. And when getting rid of GRE, we are only performing one encapsulation, the IPSEC encapsulation. So we have the original IP header and the IPSEC IP header. And that is the advantage of using VTIs. We don't need GRE anymore with VTIs. So, and this is the summary for creating VPNs with IQ version 1. You will have to configure phase 1. So IQ version 1 phase 1 config, where you are allowed to create several combination of settings in what we call policies. So you have one transform, two transforms, or three transforms, or whatever number of transforms you may want as policies. Cisco calls them policies. So you can work with only one policy if all your remote devices are configured the same way. You don't need more than one policy in that case. Then for phase 2, you can create what is called by Cisco as transform sets. You can have one transform set, two transform sets, or as many transform sets as you want, depending on the type of remote peers that you want to work with. If you only have one type of peer that happens to have only one combination of settings, you will only need one transform set. And then in order to have a crypto map, you have to create an access control list for each sequence of your crypto map, select one transform set, and then apply this to a wide area network interface. That is for policy-based VPNs. And when it comes to route-based VPNs, you can create IPsec profiles. You will create an IPsec profile choosing a particular transform set from the phase 2 configuration. And then you can choose to use GRE. That is just a normal IPsec profile with GRE, or you can choose to go for VTI when you are actually getting rid of GRE using this command, tunnel mode IPsec. Now, in order to troubleshoot, the commands are show crypto ISACAMP SA for IQ version 1 phase 1, show crypto IPsec SA for phase 2, regardless of whether you're using IQ version 1 or IQ version 2, and you can always use the book in order to see what's going with your IPsec conversation. So this is a summary of what we saw in this session. IQ version 1 phase 1 configuration using this command, crypto ISACAMP. Phase 2 configuration using crypto IPsec transform set. We saw how to configure crypto maps, IPsec profiles with GRE, and IPsec profiles with VTIs. That's it.